In our previous few videos, we have explored the role of descriptive statistics in summarizing data and how correlation matrices can reveal connections between variables. Now, we'll advance to the next stage, analyzing sample data to understand the broader population. This is where inferential statistics come into play, allowing us to make forecasts, test theories, and draw significant conclusions about the bigger picture, all from economically and efficiently collected data. Let's take a look at what inferential statistics are, their core principles, and why they're essential for analysts of all levels today on Art+Science. Hey there, I'm Kevin Hartman, Associate Professor at the University of Notre Dame and founder of the Art+Science Analytics Institute, where our mission is to make you a better analyst. Inferential statistics bridge the gap between available data and the data that is too broad, big, or expensive to collect. It includes various methods for this purpose. These methods help us generalize insights from a sample to a larger population, test hypotheses to determine if patterns in our sample hold true for the broader population, and predict future outcomes based on current or historical data. Inferential statistics allow analysts to work smarter, not harder. As analysts, we can use inferential statistics to draw meaningful conclusions from a carefully selected sample while saving time and saving money. Analysts can use inferential statistics to build upon insights from descriptive or correlation analyses. For example, if a pattern emerges from descriptive statistics or a correlation matrix that might suggest a potential new product, testing that idea with every single one of your customers is probably too time-consuming and too expensive to be practical. Instead, inferential statistics allows you to do a quick online survey of 1,000 customers in just a few hours and get the same results. Inferential statistics allows for analysis of survey data and application to a larger population. It can predict customer reactions and account for a margin of error. This approach is crucial in market research and other scenarios. These scenarios include A/B testing, which version of a website performs better. Inferential statistics can tell you that. Healthcare studies, understanding the efficacy of a new drug without testing the entire population. Policy evaluation, determining the impact of a new policy or program by analyzing the outcomes of a representative sample, helping you make predictions about its effectiveness across the broader population. Inferential statistics provides tools for confident decision-making. By mastering its application, you can save resources by relying on a sample instead of a full population, make smarter, data-driven decisions with confidence intervals and hypothesis tests, and avoid jumping to conclusions by understanding uncertainty in your results. Let's explore the fundamental concepts of inferential statistics now. The core of inferential statistics is based on essential principles that reveal significant insights. Using these principles, analysts can confidently predict, test hypotheses, and draw conclusions about larger populations from smaller samples. The first is random sampling. Random sampling ensures a fair representation of the entire population by minimizing biases. Every member has an equal chance of being selected, making inferential methods more valid. Sampling distributions show how sample statistics behave when drawn from multiple samples of the same population. This concept is crucial for understanding variability and forming confidence intervals and hypothesis testing. It really guarantees that the average of all sample means will approach the population mean with a sufficient number of unbiased large samples. Confidence intervals estimate the likely range of the true population, taking into account sampling errors. A 95% confidence interval means that in 95 out of every 100 cases, the true value will fall within the interval if the same sampling procedure were repeated. This margin of error acknowledges uncertainty and allows for accurate conclusions to be drawn. Hypothesis testing evaluates population assumptions. By calculating the probability of obtaining observed data under a specific assumption, analysts can determine whether to reject or accept that hypothesis. This structured approach differentiates between random variation and meaningful patterns in forming decision-making. P-values measure evidence against the null hypothesis. A smaller p-value, something smaller than 0.05, means that observed results are unlikely due to chance. This allows us to confidently reject the null hypothesis and consider alternative explanations for the patterns that we're seeing. Inferential statistics can help you make informed decisions based on data. Here's an example of inferential statistics in use. Let's say you're an analyst for a subscription service. To test the effectiveness of a new onboarding program in reducing customer cancellations, you would randomly select 500 customers and put them into the program while keeping a close eye on 500 others that you keep out of the program in what we call a control group. By monitoring retention rates for both groups, the group that is in your onboarding program and the group that is not, you can use hypothesis testing and metrics such as p-values to determine if any differences you see in retention rates are statistically significant. With this information, you can confidently recommend implementing the program if it appears that it is working, or consider other strategies to improve retention if it doesn't. This small-scale test helps you by saving time and money that you would have invested if you had rolled that program out to your entire customer base. And maybe more importantly, it's going to save you all the headache and the losses you would have incurred if you rolled that program out and it didn't work in the first place. Examples like this highlight just how important inferential statistics are to you as an analyst and how important it is for you to understand them and build them into your practice. Next week, we will dive into the practical applications and the limitations of inferential statistics. We'll learn how these techniques are used in real-world scenarios from A/B testing to market research, and we'll explore their pitfalls. Thanks so much for watching. If you haven't already, take a moment and subscribe to this channel, like this video, and share it with anyone who you think is interested in data analytics. Every single week, we are bringing new, exciting, and important videos on data analytics to this channel, and we would love to have you there for the journey. Be sure to check out the links in the description for this video below for additional Art+Science resources, and sign up for our newsletter to get exclusive tips, course updates, and more directly in your inbox. Thanks again for watching, and we'll see you in the next video.